Hello, Mariya.
Hi, Nash.
Cheers.
No coffee for you, but it's okay.
Tell us, what do you want to talk about today?
I want to chat about brain encephalization because it relates to my favorite topic of all, food. Encephalization has to do with the relative size of the brain to the body mass. And you calculate it for a whole range of species and have an expected brain size based on what animal it is.
Okay.
So the reason I want to talk about this is that human brains are really weird. Our brains are about 1 kilogram larger than you would expect for our size.
Wow.
I know it's a lot. It's actually about 4.5 times larger than you would expect for a primate of our body mass. And we spend more energy on it than other primates. I was interested in how in the world can a human body actually support such a big brain.
That's the main issue here, right? The energy. How do we get the energy there? Okay.
So the thing is, brain tissue is very expensive. Not in terms of money, obviously, but in terms of calories. So primates use about 9%. Their brain uses 9% of their body's energy reserve in a resting state, and ours use about 20. And what would you expect if you have a larger brain that just needs more calories? You would at least expect that the body's basal metabolic rate would increase to kind of help that brain exist.
But there is no increase in our basal metabolic rate. It's actually the same as in an average mammal of our size, while our brains are bigger than expected. That's the mystery. If our metabolism is not providing more energy for this unusually big brain, what is?
Basal metabolic rate is the energy we spend when we don't do anything. So if you're lying down on a couch watching Netflix and waiting for quarantine to end. So if you're gonna get a brain that's larger, you need that energy to come from somewhere.
How did our body accommodate with this big brain?
Okay, so we know our body is not making more energy somehow. Then it means that this extra energy has to come from food.
Oh, yeah.
Okay, so what is it about diet? Well, we've known that humans have transitioned to a high-quality diet at some point, which could have allowed more energy to come to the brain. In the past, a high-quality diet would mean highly digestible, energy-rich foods.
Wow.
And that's a problem in the past. So things used to have lots of fiber, like 3 calories. You had to dig like 1 meter into the ground just to get that root. Then you had to grind it, then cook it. It was like the whole deal.
Hold on, I want to pause and clarify this point here. Today, many of us might think of a high-quality diet as rich in nutrients, but also not too high in calories. So not eating too much, because many of us have access to cheap calories, such as junk food. But in our evolutionary past, before we domesticated plants and animals, getting enough calories or energy from food was a very big challenge. Like I said here, wild plants would have a lot of fiber we could not digest, very few calories. And eating such plants is a low-quality diet in evolutionary terms. So a shift to a high-quality diet, one that includes foods rich in calories that are easily digested, was crucial because our enlarged brains needed a steady supply of extra calories.
So when did even that expansion happen?
So there were 2 times in our evolutionary past when the brain got bigger. First time, about 2 million years ago, and then 800,000 years ago where it got to the way it is now, basically. Of course, if we're thinking about diet, if I'm saying that the high-quality diet is what led to this, we need to show that it happened before that, right?
Right.
What exactly happened? 2 main things: cooking and meat eating. We've been eating animal foods for a very long time, 3 million years or more. And for a while, it was considered that fire wasn't controlled until like 200,000 years ago. That's why people didn't think cooking was a big deal for brain enlargement. But then there was more evidence, and now they're placing cooking at least 1 million years ago.
Oh, wow.
But there's a lot of talk right now that it could go back at least 2 million years ago, maybe even more.
We're talking about spending less energy, gaining more energy. That's what you call high quality.
So there are theories that try to explain how did we shift to this high quality diet and how did that allow for the brain to increase. One is called the expensive tissue hypothesis. It's the idea that brain is one of those really expensive organs that wants a lot of energy. It actually uses 22 times more energy than muscle. So how do you maintain it? Well, you could shrink other expensive tissues so they don't take up as much energy. One of those is our gastrointestinal tract. When you compare us to chimps, their larger intestine is so much bigger and ours are so shrinked. Why is it shrinking? Because of a high quality diet. So a poor quality diet from evolutionary perspective is a bunch of plants that are very fibrous that you need to sit there and eat them all day and then digest them. So that's why chimps have much larger colon, because that's where the digestion of that fermentation, happens. And we have it shrunk. Physiologically, we know we're adapted to a high-quality diet because our teeth and jaws are smaller, stomachs are smaller, gut is smaller. That's all adaptations to being able to eat stuff that's easier to digest.
That makes sense.
This is very ironic for me. I was a raw vegan for 2 years.
I remember that, yeah.
Oh, serious. I traveled around the country. I took classes on how to prepare raw vegan meals. I taught classes, workshops. I was into it for 2 years. That's what led me to grad school, at which point I started realizing a lot of these things I believed had just zero evidence. I still think adding raw foods, by the way, to your diet is a fantastic idea because we don't do that enough.
So, Mariya, I can imagine cooking makes things easier to digest, so we spend less energy. Is that why we started growing our brain? Because we could have more energy coming up and providing for that expensive tissue that you're talking about?
Yes, that is how our brains managed to get bigger, because the diet changed and started providing more energy.
Yes. So cooking, why is it important in our evolutionary past? Well, first of all, like you said, it decreases how much energy we're spending on digesting. Another really important thing it does for carbs is it releases glucose really well, which of course for the brain, right? What was it? The brain uses 60% of glucose stores in a resting state.
Wow.
Like it's crazy, right?
That's crazy.
Another cool thing it does is it removes toxins. So there's a lot of roots and vegetables that you can actually detoxify with cooking. When I was raw vegan and we're eating all these cashews because cashews are delicious, none of them are raw. They're definitely been boiled because the shell is toxic. They're related to poison ivy.
Wow. Doesn't it also provide you with more resources? Like, for example, like you can't eat beans, right? Like, but then if you cook it, you can eat it.
Right.
How about the change that happens in some nutrients? For example, spinach. Raw spinach has different nutrients than cooked spinach. So that also adds something to our nutrition.
And sometimes it's bad, sometimes it's good. For example, with protein, when I was reading about it, it seems like it can denature some protein, like make it less absorbable. But it could be a small price to pay for what else it does. Pathogens in meats, that's kind of a big problem. That's why we cook them, right? And there's all these rules about how to cook different meats. Oh, there was studies done showing that if we weren't cooking our meat, the average American would get sick 42 times a year from foodborne pathogens from meat, right? There is a metabolic cost to an immune response. So anytime you need your immunity to react, it costs something calorically. For, I think, 1 Celsius degree increase in temperature, so if you have a fever, will increase your energetic need by like 13%. So when you think about cooking meat, hugely important.
Can you explain what pathogens are?
Yeah, we're talking about viruses, bacteria, so all these things that can
anything outside.
pretty much invade our body, cause trouble.
What do you want to learn next?
Oh, you know, I have a couple of things on my mind. One of them, you might know because I can't shut up about it, transferring consciousness to machines.
Oh.
In my mind, you're talking about copy and paste, not cut and paste. So you could copy yourself and be happy that some coffee is in a machine, fine, but why would you care, right? Anyway, but I want to see what's being done right now in terms of that.
Do you know anyone that has done it?
No!
Is studying this kind of thing?
No!
The thing is, like, what is consciousness?
Oh.
Maybe we can learn about
That's true, we can start there. I personally welcome the rise of the machines. I'm fine if we blend with the machines and it's gonna get even harder to say what it is to be a human. You know, when you're trying to define what it means to be human, you try to think, oh, language, this, that, and then you're really looking at other animals, you're like, man, no, other animals have language, so what makes us different? Cooking! We're the only species that cooks. It's universal. Every culture cooks.
Okay.
Well, thanks for chatting with me, Nash. I've tasted my own medicine. This is hard.
Cheers.
Cheers.